Today's goal. The learner will understand how to evaluate and graph logarithmic functions. What that means. So, logarithm. Let b and y be positive numbers, with b not being equal to 1. So this base of the log function can never be equal to 1. The logarithm of y with base b is denoted by log base b of y and is defined as the following. Now, so they say log base b of y equals x if and only if b to the x equals y. Another way to help yourself remember this. Base Ben can be converted to the log of Benny. So base to the exponent equals a number. Can be converted to log of the base of a number equals the exponent. So Ben is equal to the log of Benny. Okay? So thinking about that, it says rewrite using exponential form. So 3 to the 4th equals 81. Check. 7, so base to the exponent equals the number, because that's B-N-E, Benny. 14 to the 0 equals 1. 1/2 to the negative 5th equals 32, so that would be 2 to the 5th equals 32. All those are true. Okay, because see on this one, B is 3, E is 4, N is 81 based on this. Okay, so Ben is equal to the log of Benny. That's just a trick I learned to help remember. Alright. So special logarithms. A common logarithm is a logarithm with base 10. It is noted by log base 10 or simply log. So if you don't see a base, the base is 10. A natural log is log of base e. It can be noted as log base e, but is more often denoted as ln, meaning natural log. Okay? Your calculators do have keys. So it says evaluate the logarithm. Well, most calculators we can't do this because the calculators only deal with base 10. So you have to change. So think about this. We know this equals something. 2 to what power equals 32. Well, I could change this 2 to the x, and that would be 2 to the 5th, so get rid of the bases, you would get x equals 5. Okay? So, here I would get 27 to the x equals 3. Well, isn't 3 to the 3rd 27? So I'd have 3 to the 3x equals 3 to the 1st. So then 3x equals 1, so x equals 1/3. Now this one, if I tried to convert it, I would say 10 to some power equals 12, but we can't make those the same, so that's when you just go log of 12 in your calculator, and it would be 1.08. And then same thing, natural log of 0.75. I got negative 0.29. Okay. Inverses. By definition of a logarithm, it follows that the logarithmic function g of x is equal to log base b of x is the inverse of the exponential function f of x equals b of x. That means g of f of x equals x and f of g of x equals x. So here you see how you have 8 log base 8. See how the base of the exponent and base of the log match each other? Those are inverses, so they cancel each other out. What are you left with? X. Here the base of the log and the base of the exponent match each other, so it'd be negative 3x. Now these don't match yet, so what do? You got to change that. That would be 2 to the 6th. So you get 2 to the 6x, so it's 6x. Here, e and natural log, those match, because remember, this is actually, natural log is log base e, so those cancel each other out, you just get x. So there are our final answers, guys. These are just facts that we need to know. Okay? So, find the inverse of the following. Well, remember how we said Ben is equal to the log of Benny. So, this would be, so switch the x and the y. So you get x equals 4 to the y, and then you'd have log base 4 of x equals y. So there's the inverse. So switch the x and the y. Not e. Now change this to, remember that's log base e, so it'd be e to the x equals y minus 5. The base, which is e to the exponent, equals the number. Okay? Add the 5. E to the x plus 5 equals y. So they're inverses of each other. This is where, again, we're using this. Something we need to know. Graphing logarithmic functions. Well, if you see here, we've learned exponential growths look like this. Well, reflected over the line y equals x, and you get the log function. Now think about this though. The standard domain was for exponential functions was negative infinity to positive infinity. The range was 0 to infinity. Well, it's flip it. The domain is 0 to infinity, or x is greater than 0. The range is negative infinity to positive infinity now. Okay? Because you cannot take the log of 0. And then same thing for decay. So graph the function. Alright. So here's the problem. We can't do log of 1/3 in our calculator. So what we need to do is change this. You get one-third to the y equals x minus 3. Now, we're doing inverse, but see how I didn't switch? So watch, add the 3 over, you get 1/3 y plus 3 equals x. So instead of picking x values, we're going to pick y values and plug them in. So I would pick -1, 0, and 1. Plug them in. So 1/3 to the -1 is 3. Plus 3, 6. 1 to the 0 is 1, plus 1 is 4. 1/3 of the first is 1/3, plus 3 is 3 and 1/3. So let's graph these. So I go 1, 2, 3, 4, 5, 6, -1. 4, 0. 3 and 1/3, 1. So let's see what happens if we plug in 3. Because if you plugged in 3, what's 3 minus 3? 0. So if you think about this, I'm going back to the original now. Three minus 3 is 0. So if I did y equals log of 1/3 to the 0, that'd be 1/3 to the y. Is there any exponent that makes it equal 0? No. So that's a problem. So what that lets us know is this. Whatever h is, there's a vertical asymptote. Now, and I misgraphed this because it's 6, -1. So that's going to be this, okay? Now, I think there might be a way that we can try to check on the graph to make sure, but if you needed to, pick a bigger number and see what happens. Pick 2 for y. So if I pick 2 for y here, nope, that wouldn't. Oh yeah, that would work, but it would be 3 and 1/9. So I get 3 and 1/9, 2. And then it keeps going up and up and up. So pick a smaller number. If you pick -2, that'd be 9 plus 3 is 12. So you'd go 12, -2. Okay? So let's try another one of these. Okay. So first problem is we can't switch yet. So I'm going to change this to y equals I got to add the 2 over, so I get y plus 2 equals log base 4 of x plus 1. And then if I change it to exponent form, I would get 4 to the y plus 2 equals x plus 1. Subtract the 1. So again, we're picking our y values. So let's do these. Well, let's look back. X plus 1 has to be greater than 0. So x has to be greater than -1. So let's just see what happens if we pick our standard go -2, -1, 0, 1, and 2. Okay. If I plugged in -2, 4 to the 0 is 1, 1 minus 1 is 0. If I plugged in -1, I get 4 to the first minus 1 is 3. If I plug in 0, I get 4 squared, which is 16, minus 1 is 15. 4 to the third is 64, minus 1, 63. 4 to the fourth is 64, or 256, so 255. So these get pretty big. So maybe what I would do to make sure we can graph a little better, erase the bigger ones, and I pick like -3. See what happens at -3. What's 1/4 minus 1? -3/4. If I pick -4, 1/16 minus 1, -15 16th. Now, remember what we said. So, at -1, there's going to be that asymptote, because it's always what h is. H is -1. So let's graph these points now. 0, -2. -3, -1. -3/4, -3. So see now, so the range for every single one of these are always going to be negative to positive. The domain is always going to be h to infinity. Okay? All right, we'll see you guys tomorrow.